So we're going to solve some word problems. Remember, these are linear systems, so you have two lines, right? You have two lines that you're going to have to find a solution for. We've learned three different ways. We've learned graphing, substitution, and elimination, right, to solve that point of intersection. So after ticket sales at a volleyball game, a cash box contains 87 coins in loonies and toonies. If the total value of the money is $161, how many of each kind of coins is there? The situation can be represented by the following system of equation. Let's say they did not give us this system of equation. Let's say they did not give us these two, right? Remember at the beginning of the course, of the unit, we made up these equations. Do you guys remember with the let statement, right? So at total I have loonies and toonies. How many of them do I have?
87.
In together. 87 loonies and toonies, right? So loonies plus toonies equals to 87 coins. You guys remember that? Yeah? So this is one of the equations. Now, the money, right, for the loonies and toonies, they equal to $161. How much is the loonie worth? $1, right? So $1 times L, right? How much would a toonie cost? $2. So that would be 2 times the toonie, right? So if you add 10 toonies, 2 times 10, that gives you $20, right? Altogether, if you add the value of the loonies and the toonies, they're going to equal to $161, right? This is where they came up with the second equation. Do they make sense? Yes?
Yep.
Okay. So they tell us that L represents the number of loonies and T represents the number of toonies. Remember when we used to have to do this? We had to do a let statement, and we had to say let L be the number of loonies and T be the number of toonies, right? But this is already done for us, so it's easy. Now the question is asking you to solve the system of equation by substitution or elimination. So you have the choice. Which one do you want to do? Elimination. Why elimination? Why? Why not elimination? Can I do elimination?
Yeah.
Yeah, because both L's have the same coefficient, right? So I can do substitution. It's easy. Can I do substitution? Yes, I can. All right, but it takes a little bit more work. Let's do which one? Sure. Okay, so let's do substitution. So what's my solution?
Move the L from the first equation.
So isolate for 1,
Yeah.
right? So which one do I isolate for? Let's isolate for L, okay? So I'm gonna move the T over, okay? So that's gonna be L equals 87 minus T, right? So what I did is I took equation number 1, I moved the T over to isolate for L. I'm gonna call this equation number 3, right? Now, what I have to do is I have to substitute the value of L in number 2, right? So 7, 3, and 2. So instead of L, I'm going to replace this L with its value. Oops. So 87 minus T plus 2T equals 161. You guys okay with this? So L is 87 minus T. I replace that in here for L. Okay, and everything else stays the same. Now you see that I only have one type of letter. It's only T, right? And the rest is a number. So 87 minus T plus 2T. What can I do here? What do we call it?
Like terms.
Collect like terms. Minus t plus 2t, what do I get?
1.
Plus 1t equals 161. Then what do I have to do? Isolate, move the 87 over. What's 161 minus 87? So t is 74. That means I have what? 74 tunis. How many tunis do I have? How can I find how many tunis do I have?
Plug in t to the original, or not the original, but the remade.
I can plug in t here,
Yeah.
right? Because I know L. So that means I have 74 tunis and 13 loonies, right? So what I did is I plugged in t, right? I plugged it in here so I can find the value of L. What can you do to make sure that your answer is correct? Check, right? By plugging in t and L back in the original equation, make sure the left side is equal to the right side. Are you guys okay with this?